So we're good to start. Okay, so thank you very much for hanging on. So right now we have speakers. We have Casey Udumuku, Systems Engineer at Cisco, and we also have Mr. Yinka Adeoshu from Signal Alliance as well. So they will both be anchoring this session. So let me hand over to them. If we have questions, feel free to ask. There's a question tab at the top right corner of your screen. Feel free to ask questions as we move on. So this webinar is going to last for 45 minutes, and it's going to be interactive. So I hand you over to them.
Yeah, very good morning. My name is Casey. I am a system engineer at Cisco. Today we are going to talk about software-defined access, and I'm sitting with Yinka from my partners, Signal Alliance.
Yeah, good morning, everyone. My name is Yinka Adeoshu. I'm the solution architect for Signal Alliance. We'll be anchoring the technical briefing on software-defined access, what it means to our business, how it will address our business challenges, and also be in the forefront of what we intend to do in the near future so that we'll be able to easily drive our business successfully.
Okay, that's fantastic. Now, for software-defined access, we'll give you a brief technical overview of what the solution is and what benefits it brings to our business as we go forward. So the question now is, this is the agenda we're going to be working with, the key benefits, key concepts, the solution overview, and putting everything together, and the key takeaway from where to get started from. Now, what are the key benefits? Why do I care about software-defined access? The thing is, the networks are changing, business is changing. We need ability to innovate in our businesses very fast. We need ability to change things. We need our network to be able to give us full insight and action of what is happening in our network. We need automation and assurance for our network at the same time. And we need a highly secure network that is also compliant. Now, in this new digital age, it is only a software-defined network, like Cisco would call it, the full Cisco digital network architecture. This Cisco digital architecture has software-defined access as part of its subset, software-defined one as another subset, and software-defined data center as a subset. Today, we are going to only treat software-defined access. This deals with your campus environment and your branch environment. Now, what are the key benefits of software-defined access? Very simple. Number one is it streamlines your network design to very simple form and simple format that enables easy provisioning and management. It simplifies provisioning on how you deploy devices, both in a small branch or to a large campus. It allows you to have full-time segmentation, so you can break your network into smaller groups and manage it more efficiently and more effectively. And you can enforce policy decisions all around your network, irrespective of the location, the user, or the type of device, wherever they are connected to in the network. And it gives you insight and telemetry to manage your network. You need to see what is happening at any time. Now, what are the key concepts? What are the key concepts involved with the whole software-defined access? Let's break it down first. Then we'll break it down into high-level view, roles, and platform, and what kind of devices or fabric make this to come to pass. So the question we've always asked is, what is software-defined access? Very, very simple. We automate our network. We simplify process where the software controls how stuff happen in the network. Now, let me break it down a little bit. Traditionally, we use the CLI to talk to our devices. Now we are moving from the age of human to device communication with traditional CLI to the age of machine-to-machine communication using APIs. These APIs are designed over the industry standard of netconf/YANG or RESTconf/YANG. Now, in a scenario for software-defined access, we have terms like code fabric, which will be what the whole network is built around, and we have the automation and assurance on top of this full fabric. We have the ability to separate the management plane, the control plane, and the data plane. And for you to be able to achieve this, you need both devices that have programmable ASICs and also converged software. Both of them go hand in glove. You have to have the ability to program your ASICs, and you also have the ability to program the software. Now, to look at it holistically, what else is key in this? There is a feature called the DNA Center. The DNA Center has three things inside: the Identity Service Engine, the APKM, and the Network Data Platform, all riding all over the devices. Let me stop here and break it down a little bit. Let's go backward. When you're doing concept of software-defined networking, software-defined access, the traffic moves in different patterns, what we call northbound and southbound. Traditionally, the way we talk to southbound is, when we say southbound, we're talking to the devices, the wireless, the hardware, the controllers, any of the physical devices downwards will be the southbound traffic, while the upwards will be the northbound traffic. In this case, I will explain further how we'll be able to, how you identify the different planes. So in this case, we'll be able to separate the control plane from the data plane. Most of the traffic upbound may be the control plane traffic, while the southbound traffic most times will be the data plane traffic. Now, I would explain that in future slides in front, so don't get confused there, but let's follow it step by step. So the SDA helps us in the design stage, the hierarchical design, simple network setting, and easy GUI management of everything. Provisioning and onboarding of devices, very simple GUI method. You could bring in host or devices automatically with the GUI. You could set policies, like I've mentioned, from a GUI interface. Set policies according to the business needs, not according to each device. So you create assurances and management and see what is happening in your network from anywhere in the world, as long as you have access to that management plane. So let's go back 2 steps to what I tried to explain before, the northbound traffic and the southbound traffic. In our traditional network, we have each device, either it's a router or a switch. We have what we call the traditional plane, where there's a control plane and a data plane for each network. A control plane, a data plane. Each device on the network has control plane, data plane. Now, so I assume you have 1,000 devices in your network. With the CLI network which we do, that means you're configuring 1,000 devices end to end. You're configuring 1,000 devices each, control plane, data plane, control plane, data plane. And the funny part is, how do we now transition to an evolved software-defined network? The very first step is to decouple the control plane from the data plane. So what if I have a centralized control plane and I have a separate data plane, where the centralized control plane can manage all the 1,000 devices from one spot?
Okay. Yes. So there's this one is not making noise inside.
Where the central control plane can manage 1,000 devices from one spot. So that makes, yeah, I'm looking at my network as a system and not as individual unit. So instead of me going into 1,000 devices one by one to manage them, I have accumulated all the control plane to central point, and I now manage all the devices from this central point. Now, how am I able to achieve this in a modern network? That's where the term I mentioned earlier comes into play. NetConf and YANG comes into play. NetConf is the protocol that enables this communication up from the down to the data plane. and this control information works over what we call, or let me put it this way, is built over Python. Python is the means of the communication. So your devices now have been built to understand, to receive Python information, so that when you're sending this information through REST APIs from the control plane down, everybody is in sync. Okay, so how do we now make this happen for a full network? We'll separate the data plane, like I've been saying, with the control plane. So we'll build it like a fabric. A fabric is what we is like an overlay, a logical virtual overlay that we put on top of devices. The underlay may be the data plane, the overlay may be the control plane, or if I separate it differently, if I connect all the hardware physically at the layer 1 level, I can put a virtual overlay of layer 2 on top of all the devices seamlessly, and I'll put a virtual layer 3 overlay on top of it seamlessly. Now, why am I doing this stuff? Why am I putting overlays on top of the whole network? Why am I not just treating the network individually like one device or the other? The plan is simple, so that I can manage my network as a system, not as individual boxes or individual devices. If I'm able to manage my network as a system, it automates management and processes where the devices themselves become dumb units, and the control plane that has all the intelligence have been moved up to a controller. That controller up is what I have defined earlier on as the DNA center that sits at the center of the network and controls everything that happens under it. Now, the key components of this SD access are actually based on three things: the control plane, which I've always said, the data plane, and the policy plane. The control plane is built with the protocol LIPS, location identifier separation protocol. The data plane is built with VXLAN, and the policy plane is built with Cisco TrustSec. These are the three parts of the fabric that makes up the SD access, any day, any time. Now, what do we mean by building the control plane with LIPS? Like I've been saying all the while, traditionally, if you look at the left of my diagram on the before part, each device has its full routing table, control routing table, layer 2, layer 3. Each device has that information. But if we move to this evolved programmable network where we have moved all the control plane to a central location, and only the devices now are on the original location, what we now have is a scenario where each of the local device only has knows about itself, the address of its directly connected neighbor, and the address of the mapping server, which is the control server. So each device, any routing or forwarding that is taking place at that control plane layer, all the routes will be moved to the server at the center. We could call it the mapping server, we could call it the controller, we could call it, as Cisco calls it, DNA center. So you can see what has happened in this case. Because the devices now do less work, we may not run into any situation of over CPU utilization, or we now have different scenarios where the devices are running extremely fast because they are empty. They only know themselves and their neighbor and the mapping server. The mapping server takes all the decision and forwards incoming and outgoing packets wherever that might be going to or coming from. That's how the control plane is built. So you have an original IP packet that will be modified to have the LIPS packet is embedded in it. And we also have the same packet. If we modify it further, we can embed the VXLAN packets for the layer 2 segment inside of it. So you can see your regular packet has been extended from the traditional size to something bigger. Now, in this LIPS that we built, that I mentioned previously, because of the new packet size, the protocol running under the LIPS is not your traditional OSPF or EIGRP. What is running under the LIPS now would be ISIS. It's part of the building blocks of LIPS. ISIS, we know, is a CLNS protocol that allows you to add more bits or bytes to a frame and can move that frame from point A to point B. Where LIPS is an advantage, is a location identifier on each packet. So the controller at the top knows which particular layer 2 device or layer 3 device under it is originating that packet and which destination it is going with the help of ISIS, which is embedded into the LIPS with the identifier protocol on the LIPS. I hope I'm on the same page.
Yes, to add up to what he has explained further, just to simplify it, what the LIPS control plane would do for us is that it allows, if you have a stretch subnet, imagine if you have a stretch subnet that can accommodate up to 2,000 nodes. And then this subnet should be able to, in this form, you should be able to, regardless of the location you have, you should be able to talk to your layer 3. Whether you are from, regardless of the location, you'll be able to talk to the layer 3 seamlessly. So that's what XVLAN does. So if you're moving from location 1 to location 2, the same VLAN that you need to tie to, whether you're in location 1, will still be available for you when you're in location 2.
Yeah, but that's fantastic. Like, if you explain it further, it means it encourages host mobility.
Exactly.
So the host can move in from any of your branches, from Lagos to Abuja to Kano, and they still carry their policies that you set on them, irrespective of the office they are in. Now, it is not a function of the switch port that their PC is plugged onto. It's a function of the individual and the policy set on the individual. And that leads to the third part, the policy plane, where the individuals are built with security, Cisco TrustSec, to build policies around it and the business, so they could now move independently, irrespective of where they are on your network. Now, this is the architecture. We want to put it up together. Now, because the concept now has changed, the names of the devices too are changing. Back in the day, we are used to things like the access, the distribution, the core switch, blah, blah, blah. But the concept now is changing because we are building it in a fabric format. We are hearing new things like the control plane, the fabric border plane, the ICE, the analytical engine. So this diagram in front of you explains it differently. Our traditional access switches, which are now part of the fabric, will not be called my access switch anymore. They'll be called my fabric edge node, which is the first device that connects to the host or to the APs at the endpoint at any point. Now, if we have those guys on it, we could have, if you look very well under the diagram of the campus fabric, you could see some blurred out switches. So we could do traditional connection under distribution, access, aggregation, call it whatever I want to call it, but they don't play significant role anymore, just connectivity roles. That's what they do. At the top of the edge, we now have what we call our fabric border nodes. These are now interesting nodes. These are nodes that connect us to external, say, or frankly, to more resources outside our internal node. It could be our traditional core switch that sits at the center of the network. It could be the biggest kid on the block that sits at the center of the network and gives direction to all the packet. Now, above this fabric layer is now the control layer on top, the DNA center. The DNA center has 3 devices inside. It has the ICE, the identity service agent, running side by side. It has the analytics engine on the NDP, and it has the APKM. Let me break down the last two, the APKM and the NDP. The APKM is application infrastructure controller enterprise module. You do all the, I like calling these things AVC.
Yeah.
You see everything, the control, the visibility, the application, you see it on this APKM, and you take decisions on this APKM. The NDP, to me, I like calling the network data collector. I like calling it in the previous diagram I showed you, where all the mapping server that stores all the routes on the layer 3. So that's the server that stores all those routes, and the intelligent decision of route forwarding and packet forwarding takes place in this NDP. That's why we call it the analytics engine. That's the key to this whole network. If it goes down, network is down. But the good part now is that because they run on the server, we can easily back up that server and have multiple instances of that server running and create priorities on the server. If A is off, B should continue. But after it picks up initially, after the first setup, it runs. Even if that server is not existing for a while, the network will still be running automatically because you already have know the directions where things happen. Now, once we have this fabric stable, we can now add the wireless controller to the mix. The intermediate nodes are the nodes like the aggregation switches that you have that they don't really play significant role anymore, just to aggregate links together. You want to add anything to that? I should continue. Okay. Okay. So let's take a simple example of how the control plane tracks each individual that comes up to the network. Once you come up to the network, the host plugs to the network. With the way lips work, it will attach an endpoint ID to that particular host. That endpoint ID would do a lookup on the host IP address, IPv4, IPv6, or even MAC address lookup. Once it receives those information from the network, the control plane resolves this end host and moves it forward onto the system. Then that end host is already registered in the system. Okay, that end host is already registered in the system, so it knows, okay, this is the end host and where it is plugged onto the system, where it is on the particular border, whether it is border node ABC or border node XYZ. The fabric knows where that host is plugged and knows the policies involved with that particular host. Now, for today, previously I mentioned for you to achieve this, you need programmable ASICs and programmable software. These are devices we could use at the access layer, let's call it the edge node, that have programmable ASICs in them. It's Catalyst 3K, Catalyst 9500, Catalyst 6K, and the ASR 1000, 4000, and the CSRV. These folks are folks that support this architecture from the control plane and at the access node. If you move in, sorry. Okay, thank you. Like I specified earlier on, the edge node is responsible for a whole lot of things. It's the first hop service for the users. The first hop service for the user is responsible for identifying and authenticating. It's responsible for registering the endpoint with its unique ID. It provides any cast for the devices to move irrespective of what port they are in on the network, and they encapsulate and discapsulate data traffic on the network. So these are the devices that make it happen on the edge node. Now,
to add to the edge node, one of the key things the edge node does is that is all I will call the routing table collector.
Yeah.
It collects all this routing table and pushes to the analytics engine at the top, which aggregate the entire table and know how to push it down to the entire network. So if you imagine if you have over like let's say you have over 100 or let's say almost about 200 routers scattered across your network. Each of the routing table being picked up, each of these will be repository back to the analytics engine, which redistributes it across your network. So instead of having these things converge into a single, what I'll call the core or the core router or the edge router, the control plane is the one that handles this and push it down to the entire network, rather than overboarding your what we so call the core switch or the core edge router. This analytics engine is the one that catch and push the routing table across the network.
Yeah, thanks, man. Now, for the border node sits at the edge. The border node acts as the entry and exit point on all data traffic going in and out of that fabric. And there are two types of border node. There is border node for known traffic in your company, and there is border node for traffic outside your company. We call this one, the first one, fabric border. The second one, we call it default border. Why did we separate them? Because the security policies of the two are different. The way you treat traffic inside your company is totally different from the way you treat traffic going out of your company or coming from outside. This border node advertises endpoint routes to subnets both inside and outside of your network. It exports all internal IP pools to the outside, aggregates them. In fact, it's only the part that is allowed to speak traditional routing with the outside. So while it's talking fabric to you inside, it's speaking traditional routing outside to external devices. We could say like the function of a NAT device, some sort of what the NAT used to do, translate your public IPs to private IP. This guy sits at that point. And it's the guy that knows the internet, has the routes to the internet, it's the guy that exports all your IPs to the external flow, and at the same time, you create all kind of stuff with it. These are the same set of devices that can play in this role, just like the same set of devices that have been playing in any of the other roles, just a function of what application and the size of your network you want to do. Now there's something different here, the way the wireless controller have been added to this network. It has been added to the fabric to sit at a particular significant point of the network to provide resources for everybody, both your local branches and maybe your external branches. The wireless controller sits at the middle, at the edge of the network, and has this overlay functionality for everybody on the network, irrespective of what SSID the client will be using to log onto the network. Now, the CAPWAP has been designed to flow over the VXLAN. The CAPWAP tunnels is a tunnels for the access point they use to talk to the controller. They flow seamlessly over the VXLAN, carrying traffic information from one host to another host, etc. Now, these are the different type of controller involved, story. Now, so now let's look at the key concepts involved in building a fabric like this. We mentioned previously that you could have host mobility. You could have users move from one point of your network to another point of your network. But also in a network like this, you could have virtual networks run. Virtual instances of the routing or the switching running separately on the same set of hardware, on the same type of hardware, but different routing and switching table. So we could build virtual networks on this same fabric, just like a fabric pattern. Traditionally, those stuff will be called VRF, stuff like that, but we could build these virtual networks on this fabric seamlessly. So on a simple fabric, I could have multiple virtual networks, virtual network A, virtual network B, virtual network C. And in each of these groups, we have secure group tags. Group tags is like a logical aggregation of groups or users in one particular group, which is where the TruckSec comes into play, secure group tags. So each of the group policies of the individuals go with the individual of the host according to the group tags and policies which we have created as they move from one part of the network to another side of the network. I know I've said a lot of strange technical things that are confusing some low-entry technical users right now.
You can imagine somebody that's having a tie to a regular VLAN 10, for example, could be an HR resource, and he's on the first floor, and every time that he wants to move a table from first floor to the third floor, the engineer has to locate the cable, check the switch port, then go to the next the switch that is allocated to the third floor and allocate the VLAN to that user on the network. But in this sense now, what happened is that regardless of your location and boundary where you are, there is a virtual routing table, virtual network being created on your fabric. So if you are moving from first floor to the third floor, this network is of your identity as you're moving. and in which sense that even though you are in head office and then you are in branch 1 or you are in branch 2 and you branch 3, the virtual element of the network has been created and provisioned for you. So just like having your network moves along with you as you move from within your corporate network.
Yeah. Continue. I'm just trying to reduce the amount of technical information I am giving out, not to confuse a lot of our users. We've explained how the Ellipse works with the VXLAN TrustSec on top of it. So let me see how we put all this together. How do we put all this story together? This is more information. Yeah, this is how we put it together, where it becomes simpler for everybody involved. Now, we've been giving you the technical brief of how these whole things are built up step by step, the VXLAN, we did not really say much about the Cisco TrustSec. It's just a group tagging for individuals where you apply security policies. But note this, that are all the technical briefs you need to bother yourself with, because this whole process has been automated today. This whole process has been automated, so it has been built over programmable APIs, smart CLI macros. We put it all together to a GUI DNA center node. So don't bother yourself with knowing how to configure CLI for 1,000 devices. You don't really need to bother yourself with learning programming step by step on each box. It has all been consolidated to a GUI node where we call the DNA Center GUI. So how does the DNA Center GUI work for me? Very simple, just 4 steps. You design where you want it to go, you create the policies, you provision the devices, and you run assurance for network health. These are the 4 simple steps to make you move to software-defined access. 4 simple steps, very straight to the point. How do we design it? You set up according to location or users, simple things you do traditionally. Okay, this is a building in my campus. These are the global site identification for the building. These are the set of IP pools I want to make it happen. And this is the wireless SSID. Bam, the design phase is over. You input all this information into the DNA center on the GUI interface. And it creates all the required policies for you and moves forward. You go down to policy and claim on the users. Do I use secure group tag on every user, or do I use specific policies on every user? Do you have the option to import policies you have on your Active Directory, policies you have on your ICE, and tie those same policies on the individual or on the group the individual is placed into? So the policies that those individuals have are network-wide group policies, not policies per device. So the way your Active Directory manages your users, you could tie that to your network and it will be very seamless. Whether these guys are virtual networks or real traditional physical network, the policy goes with the users seamlessly. And we click apply. Once we click apply, it provisions, we add the devices, we set up the host, and bam, we are game. The network is built. Now, the DNA center will generate configurations. It will generate different, how like call the CLI testers, and push this to the devices automatically. You, the user, just sees the GUI in front of you while all this stuff runs beneath the screen under you. And it gives you an assurance dashboard that shows you 360 degrees real time of everything happening in your network. So your network is more proactive and can manage itself more intelligently. Even it tells you when there will be errors, even without you knowing there will be errors. It gives you client statistics, real-time summary of what is happening to each of your hosts and user at any time. Very simple, straight to the point. It also tells you your application performance. How are your application performing in real time? Now, you see, that is straightforward. I wish we would have time for a demo. I would have demoed this for you. It's simple 3-step. At the top, you design, you provision, you apply policy. Bam, that's it. You design, you provision, you put the policy, you click apply. The screen in front of you is exactly how the DNA center will look like. You log into it with your username and password, and you're game. The key takeaway here is that, in summary, is this. The control plane is built on LIPS, the data plane is built on VXLAN, the policy plane is built on Cisco TrustSec. This allows mobility of users irrespective of where they are on your network. They can move seamlessly with network group-wide policies. Their policies can be tied to their Active Directory policies or their ICE policies in your network. Management of 1,000 or multiple sites you have can be done from a single pane of glass, and the network is more proactive and more intelligent to show you where there are problems on your network and your routing path, which reduces the day-to-day basic challenge the network engineer sees every day, which enables the business to innovate and have more time for new things. You want to add more to this, sir?
Yeah, what I want to add is that one of the key things I know and I love about the DNA Center is allows you to be able to do a form of drag and drop.
Yeah.
So you see lists of all your devices that are already imported into the DNA Center, and it allows you to drag and drop them in a location mapping. For example, if you say you've created a virtual fabric, for example, meant for branch A, and you want users in branch A to have access to that same virtual fabric in branch B, you can easily drag and drop and copy these seamlessly without you having a full technology understanding of, or let's say full technical aspect understanding of how to do programmability, do creating a form of scripts to push all this down. All these are done for you at the background by the DNA Center.
Exactly. So you don't really need to do any more things. You don't need to do a lot of hard work. It's now GUI based. Now, why we have this on the screen is in case you need more information on how to get step by step, how the more technical details and nitty-gritty on this topic we presented. Here are some public documents by Cisco that can help you to get more information on this. We've only just set an introduction, not the full end-to-end, but we believe by the time you go through this, you'll be able to understand most of the things we have said already. Now, that is key for you, how you could move your network from what you're doing today to a fully software-defined access network. This is the official way to go about it. Although, for those that us in the black hat, there are other ways to go about it. Don't mind me. Yeah.
All right. Thank you everyone for listening. I don't know whether there is anybody that have a question.
Questions.
We have about 5 minutes more to be able to answer any few questions that come in.
Any questions?
Okay. In absence of no questions, this webinar will be shared with everyone. I mean, will be shared online. It will be available for any future view on YouTube. It will be published for us on YouTube. So if you still want to rerun through this, it will be available. Thank you for listening, and we hope you will get back in any of our future webinars that will be hosting with you. Thank you very much.